So let's start the single phase induction motor. In the single phase induction motor, we will discuss the working principle. So our learning objectives in this lectures are the introduction of single phase induction motor, construction, working principle, double feed revolving theory, which explain why the single phase induction motor is not self-starting, starting methods, and the various types of single phase induction motor and the application. So as far as the construction, there are mainly the two parts, stator and rotor, where the stator is the stationary unit which carry the single phase winding. When the AC supply, single phase AC supply is connected with the stator winding, it produces the single phase pulsating flux like this. This is the alternating flux, and when this alternating flux linked with the rotor conductor, so it produces a torque. And rotor is a rotating torque which normally is squirrel cage type. So in the construction there are two main parts, stator and rotor. Now the working principle of single phase induction motor, as you know, the single phase induction motor stator carry the single phase winding, and when we connect the single phase supply, the stator produces the single phase flux. This is a pulsating flux, means half cycle is a positive and another half cycle is a negative. When this pulsating flux linked with the rotor conductor, it produces the torque. When the positive portion of flux connected with the rotor, then it produces the forward torque, and negative part of this pulsating flux when linked with the rotor conductor, it produces the torque in the reverse direction. So in half cycle, rotor conductor torque is forward direction, and half cycle the rotor torque in the opposite direction, and the duration of one cycle is very small. So when the continuation forward torque and backward torque in a very short duration of time, then due to moment of inertia, the resultant torque of the rotor is zero. So we can say the single phase induction motor is not self-starting. So we can say the single phase induction motor is the not self-starting motor, because due to moment of inertia, rotor will not rotate in any direction. Double feed revolving theory, and by using double feed revolving theory, we can explain the why our single phase induction motor is a not self-starting. So pulsating sinusoidal flux of stator can be resolved in two equal parts. Each part of flux will rotate with synchronous speed, the given by 120 F1P in opposite direction. So in this way, this is the pulsating sinusoidal flux and can be resolved in two equal parts, part A and part B. Part A will rotate in the anti-clockwise direction rotation with the synchronous speed, and part B will rotate in the clockwise direction with the speed, synchronous speed 120 F1P. Means the part A and part B magnitudes are equal, half of the flux 5A to 5A2, and each rotate with the same speed but in opposite direction. So at stand theta equals to 0, at the point 0, when the component A and component B was in the x direction, the total flux is phi A. So the net flux is phi A. Now at any stand theta, any angle, so component A travel angle theta in the anti-clockwise directions, and part B travel in clockwise direction the same angle theta. So the resultant flux, component of A toward the x-axis, component of V toward the x-axis, equals to 5/2 cos theta plus 5/2 cos theta. So total is phi m cos theta. So at any instant theta, the net flux is phi m cos theta. At angle theta 90 degree, after 90 degree rotations, so A rotate 90 degrees, reach here, B rotate 90 degree, so reach in the downward direction. So this is the point, when A in upward direction, B in the downward direction, magnitudes of A and B are equal but in opposite direction, so resultant flux equals to 0. So this is the case at the 90 degree resultant flux is 0. At the instant when the theta equals to 180 degree, after 180 degree rotation, after 180 degree rotations, so in this case the A rotate in the negative of x direction, we also come in the negative of x direction. So this is the figure corresponding to theta equals to 180 degree. So resultant flux in the opposite of x axis, so phi by 2 plus phi by 2, the total is minus of phi flux. So at 180 degree rotation, the resultant flux is minus of phi m. So the net flux is minus phi m. Similarly, at tan theta equals to 270 degree, after 270 degree, so A will come in the downward direction and B will reach in the forward direction. The position of A and B in the reverse. So A will be in downward direction, B will be upward direction. The resultant flux is again 0. So after the 270 degree, at the 270 degree, the total flux is 0. So in this way, at instant theta equals to 360, which is the same as the 0, so the total flux is phi m. Total flux is phi m. So in this way, we can say we can resolve a pulsating flux in two parts, A and B. A rotate in the anti-clockwise direction and B rotate in the clockwise direction by the same speed. The part A produces the forward torque and part B produces the reverse torque. And the total torque is the sum of torque produced by the part A and torque produced by the part B. So the net flux variation is pulsating nature. So we can say the pulsating sinusoidal flux of stator can be resolved in two equal parts. Each part flux will rotate with the synchronous speed in opposite direction. Forward for flux which is rotating in the clockwise directions, forward torque, and backward flux produce torque in the opposite directions. Magnitude of forward torque and backward torque is equal and opposite, hence the resultant of both the torque is 0. So the starting torque is 0. So we can say the single phase induction motor is not self-starting motor. Now how we can start the single phase induction motor? Because the starting torque is 0, the single phase induction motor is not self-starting motor. So there are two main methods for starting the single phase induction motor. The first is very simple, by applying a external force in any of the direction. When we apply a external force in this, so either the forward torque will increase or the reverse torque will increase. So due to the external force, the total torque will accelerate in the same direction and produces the starting torque. Second method is by using the starting or auxiliary winding. It means at the time of starting we connect a additional winding known as the starting winding or auxiliary winding. So in the presence of starting winding, the machine work at the two winding machine, and we know the two winding flux produces when produced in different phases, it produces a rotating magnetic field just like the three-phase flux. So rotating magnetic field can be produced either the three-phase flux resultant or the two-phase flux. So in this case, when we add the additional winding, the single-phase induction motor work as the two-winding machine, and the resultant of two-winding flux is a rotating magnetic field due to the phase difference. When this rotating magnetic field link with the rotor conductor, it produces the starting torque just like the three-phase induction motor, and machine can be start in the direction of stator magnetic field. So the single-phase induction motor, by the apply of starting methods, we can classify different types of machines. So type of single-phase induction motor depending of the auxiliary winding used. Split phase, capacitor start, capacitor run, in capacitor run, or capacitor start, permanent capacitor motor, and shaded pole. The first one is the split phase induction motor. In which we apply a auxiliary winding in such a way the resistance of auxiliary winding is greater but the reactance of auxiliary winding is less, because the auxiliary winding we use at the time of starting only by using the centrifugal pump. So at the time of starting we close the switch and the auxiliary winding connected in the parallel of the primary winding or the main winding. So with the main winding the current is Im and the current start to flow through the auxiliary winding. Because the reactance of auxiliary winding is less, so the angle of Ia auxiliary current with the voltage is small. Because the reactance of main winding is high, so the angle of Ia with the voltage is greater. So due to the phase difference between Ia and Im, the total resultant flux current in these directions, and it produces a rotating magnetic field. This rotating magnetic field will produces the starting torque in the rotor. So this method is the phase split type induction motor. These motors are used in washing machines, air conditioner fans, and food mixers, grinders, floor polishing, blower, centrifugal pump, and in use in the small drill, lathe, and office machinery. Sometimes they are also used to drive more than 1 kilowatt hour. This is the fractional machines. Capacitor start induction motor. In this we connect a capacitor in the series of the auxiliary winding. So in the presence of a capacitor the auxiliary current now start to lead. So the main winding is lagging but the auxiliary current will the lead. So the phase difference between the auxiliary current and main current is increased, so it produces the more starting torque. So capacitor start induction motor produces the greater value of starting torque as compared to the phase split induction motor. And the application of these motors are for more starting torque proportional for heavy load where frequent start is required. These motors are used for pump and compressors, refrigerator and air conditioner. They are also used to conveyor and some machinery tools. Other is the capacitor start, capacitor run. In this machine we use the two capacitor in parallel. One capacitor is the run which remain in the permanently with the machine, and other is the starting capacitor CS. Starting capacitor is connected with the switch. So at the time of starting we close the switch and the two capacitors are in the parallel. So the total capacitance will be add. So total capacitance is the CR plus CS. Because the capacitance value will increase, so the auxiliary current will be lead more angle as compared to previous one. So the phase difference between the auxiliary current and main current will increase more, and we know the starting torque is proportional to the sine of the angle between the main current and the auxiliary current. So the more starting torque, high starting torque as compared to previous machines we can produce. So this is the other method. The starting torque is proportional to the sine of angle delta, where delta is the phase difference between the two flux. One flux due to the main winding flux, other flux due to the auxiliary winding flux. Because this angle is greater due to more capacitance value, we connect the two capacitors in the parallel, so the total capacitance value is the increase. So more capacitance value, hence the starting torque is also greater value than the previous method. That we can use this machine two capacitance method used for load of higher inertia that requires frequent start. These are used in pumping, these are used in refrigerator or air compressor for high rating. Other is the permanent capacitor. In a permanent capacitor we connect the capacitor in permanently in the auxiliary winding. So in this way, resultant of the two flux produces a rotating magnetic field which further produces starting torque proportional to sine delta, where delta is the phase difference between the two flux. Capacitor is permanently remaining connected across the two winding. So in this is a permanent capacitor induction motor, is the same as the ceiling fan. We use this permanent capacitor induction motor in our domestic ceiling fan. We use the application this type of motor, no centrifugal pump is required. This motor has high efficiency, it has high power factor because of permanent connected capacitor, it is high product torque. We use this as the ceiling fan. Other is the shaded pole induction motor. Shaded pole motor is the simple type of self-starting induction motor. It consists of a stator and cage type rotor. The stator is made up of silent pole. Each pole is slotted on the side. The copper ring is fitted on the smaller part. So this is the pole and the slot is cut. So the copper ring or coil is connected with the smaller part. So this is the shaded part and this is the unshaded part. So when the flux producing from the main poles distribute through the shaded portion or unshaded portion, so then the shaded portion flux due to the shading coil, the shading current and in opposite flux start to flow in the shading coil. So the resultant flux will be less in the shading coil, shading portion as compared to unshaded portion. So the flux distribution redistributes, so the axis of flux is shifted from shaded portion to the unshaded portion. So the shifting of the flux from shaded portion to the unshaded portion is just like the rotating magnetic field. So the shading coil act like the secondary winding of the stator. When stator AC flux linked with the shaded coil, it produces the opposite flux in the shading part of the pole. The resultant flux in shaded part is reduced as compared to the unshaded parts. Hence the flux axis of a stator will shift from shaded portion to the unshaded portion. This flux axis shifting create current in rotor conductor. Finally, rotor start to rotate in the direction of rotor flux shifting. So shaded pole motor are used to drive device which require low starting torque. These motors are very suitable for a small device like relay fan of all kinds, toys. The most common application of these motors are table fan, exhaust fan, hair dryer fan, fan for refrigerator and air conditioner. Low rating values are electronic equipments and cool. So thank you very much.